Welcome to Chemistry with Caroline. In this video, we're going to look at the nomenclature of alcohols. So we're going to be using the IUPAC naming system. Alcohols are the highest priority group you've likely encountered so far. So alcohols are higher priority than an alkene or an alkyne, and that's still higher priority than an alkyl group or an X being a halogen. So because the alcohol is the highest priority group, we'll give it the lowest number possible. So you still have to start at one end of a chain, but you're going to number to give the alcohol the lowest locant possible. So even though I have a bromine at the first position on the left-hand side, I want the alcohol to have the lowest number. So I'm going to start numbering from the right-hand side, because then it could have a 2 for its locant. So we'll say 1, 2, 3, 4, and 5. So this is a 5-membered long chain. Had I started numbering the other direction, I would have given my alcohol a 4 locant, and that's not favorable because it's the highest priority group. So we have one substituent here. It's a bromo as a substituent, and that's going to go out in front with its locant, and so you'd have 5-bromo. And then there's two ways to do this here. I can put the locant for the alcohol in front of the entire parent chain name, or I can put it just before the modifier. So one way to do it would be to say 2-pentanol. So the OL tells me that I have an alcohol functional group, and the 2 right in front of it tells me that I have it at the 2 position. I could alternatively have put the 2 right in front of the OL, and I'll do that in the next example so we can see both ways to name it. In this example, I have a molecule that contains both an alcohol functional group and an alkene. And so I'm going to be modifying the parent chain name in 2 spots, one for the double bond and one for the alcohol. And I think it's easiest to do that by putting the locant directly in front of that modifier so you can keep track of what's where. The alcohol is still the highest priority group, so I would start numbering to give it the lowest possible number. And so that would be from the right-hand side again here. So 5, 6, 7, and 8. So this is going to be an oct derivative because it has 8 carbons in the entire parent chain name. And then I have 2 substituents here, these 2 methyls. And so those would go out in front. But I also have this double bond. And with double bonds can come stereochemistry. This double bond is an E double bond. I have a separate video on how to assign E and Z. So if you are not familiar with that or you don't remember, go check that out. But this one is an E, so we'd put out in front of everything both the number and the letter. That tells me that I have a certain stereochemistry. What position it's at is 5, and what type of stereochemistry, the spatial orientation of the double bond, is the E. So then I'd put a dash. Next, I'd go to my substituents. So I have 2 methyl groups. They're both at the 2 position, so I need 2 locants. So it'd be a 2,2-dimethyl. So the di tells me that I have 2 of them, and then the 2,2 tells me where. So even though they're on the same carbon, I still have to put 2 locants, otherwise I don't know where they both are. Now I'm going to put the locants for the double bond and the alcohol directly before the modifier in the parent name. So I'm going to go directly into the parent name. And because there's no number here, I would squish dimethyl right up against the oct part. So this is going to be 5E22-dimethyl oct 5-ene, and I just do sort of that first part, En. I don't put the E on the end because I also have an alcohol, and I'm going to put the locant there. That's 3-OL. So the OL tells me that there's an alcohol. The En tells me that there's a double bond, and then the locant is directly in front of it. So there's an alcohol at the 3 position. There's a double bond at the 5 position. So this entire molecule is 5E22-dimethyl oct 5-ene 3-ol. In this example, I have a cyclic system. When you're numbering a cyclic system, you can start wherever you want on a ring. There is no end. And so we would start by giving the alcohol the number 1 locant, since it's the highest priority group. And then I could go in either direction to number. I'm going to go around clockwise so that I give the methyl the lowest number possible after I've already assigned my highest priority group the lowest number possible. So this would be a 1-cyclohexanol derivative. When something is at the one position, the highest priority group, whether it is on a chain or on a ring, that's assumed often, so they don't usually use a locant. So the most common way that you would see this would be 3-methyl cyclohexanol. And there wouldn't be a locant for the OH. There's no locant for this OL here. And that means that it's at the one position. So that would be assumed. And that could be a chain or a ring. It doesn't matter. Whenever the alcohol is at the one position, you don't necessarily need a locant. You can put one in there, but it's not necessary. Lastly, we'll look at when there's more than one alcohol. So when there's more than one alcohol, you're going to modify the parent name by putting the prefix for the number of alcohols in the parent name chain at the end there. So instead of all, just on its own, you'd have a diol for 2, a triol for 3, tetraol for 4, and of course each of those would need locants. So if we look at this example, we have a diol derivative. We're going to number to give the alcohols the lowest possible numbers because they're the highest priority groups, and there are no other groups on this particular example. So this is going to be a hexane diol. The thing that happens when you have more than one alcohol is you leave the E in the parent name. So I would say hex because there's 6, right? And then I would leave this E here that I normally have if I just had hexane, but I would remove if I only had one alcohol and replace that with an OL. When there's more than one alcohol, you leave that E in there. And then I put the locants, so I'd say 2, 3, and then I'd say diol. So the 2, 3 tells me where the alcohols are. The di tells me that there's 2 of them, and OL tells me that I'm looking at the alcohol functional group. So if you had a triol, you would just have 3 locants, X, Y, Z, for their location on the chain or the ring, and then you would have triol instead of diol. And again, the big difference is that I would just leave that E in, and if there were substituents, you could just put them out here in the front in addition to those alcohols. So this has been a look at the nomenclature of alcohols. If you found this video helpful, please like, subscribe, and share with your friends. Thanks.